Hello, welcome back to our YouTube channel. Today we are going to see the Codechef problem that is super increasing. Okay, so we have an array A of length n that contains positive integers is said to be super increasing if each element is strictly greater than the sum of all the previous elements, right? So that is for each I from 2 to n, this should be true. Like AI should be greater than AI plus till the AI minus 1. This is the case. So let's say, for example, this case. So 3 is greater than 5, right? 3 and 5 is 8, is less than 10, right? If we sum this, it will be 18 and it is again less than 42, it's fine. But in this case, at third element, 3 equal to 1 plus 2, but it should be strictly greater than that, but it is not. So that's why it is not a super increasing array. So Seth added super increasing array A of length n with him a long time ago, but has forgotten all its elements now. That's the problem. So the only piece of information he recalls is that the value x occurred at index k of the array. That is ak equal to x. Can you tell Seth if he recalls correctly? That is, does there exist a super increasing array of length n such that ak equal to x or not? This we need to tell. So, right, we have three values. So, let's say 3, 2, and 3. That is, this one is n, and this one is k, this one is x. Okay. So, let's say we can consider we need to have three, three element at the second index. So, let's put 3 here. Can it be, is it possible that we can make here greater thing like the smaller elements? Yes, it is possible. Let's put it 1 here or 2 here. Let's put it 2. So 3 is greater than 2. That's fine. Right. Can we have something here? Obviously, we can have 1000. This will satisfy our purpose. Right. So this can be the potentially super increasing array with the scenario given. Right. And we can have any value. Here we can have one, only one or two. That is the only choice. So let's see another case why it is not possible there. So if you see this case, 333. So this is 3 as well. So what can you think? Like, let's put it 3 here. So we need two elements smaller than 3, obviously. Like the sum should be smaller than 3. First of all, here. What is the least positive element possible? That is 1. So let's say we can put here. To satisfy the condition here, we can put only 2. But if we put here 2, that means 1 plus 2, that is 3. It is not less than 3. That is a problem. So that's why our answer is no in this case. So how can we solve this problem? This is a main question, right? So how can we solve? Like we need to like construct a minimum possible thing, right? What is the minimum possible thing I am talking about? So suppose you need to reach at K position, right? So before that, what is the minimum possible? That 1, 2, 4, 8, and 16. And go ahead, like 32 and so on. Like can you can check like 1 is less than 2, right? 1 plus 2, 3. That is less than 4, right? Then again, 7 less than 8, yeah, right. 15 less than 16, right. So this is the possible, like, uh, we can say this is the super array, right? So what we can do? We are given kth element. If somehow we can find the sum till k minus 1 index, k minus 1 index, if we are able to find this sum, so that we can check like the value given. If this value is less than, then yeah, like it is possible. If this value is greater than, That means it is not possible, or equal to, it is not possible, right? So let's see this case, the third example with this scenario. So, but interesting thing is like if you if you have observed that 1, 2, 4, 8, 16, this is forming a GP with r equal to 1, sorry, r equal to 2. So what is the sum? Sum of n elements. So a to the power r minus 1, right? And r minus 1. So if you see a is 1 here, it will be cancelled out. So 2 minus 1, it will be cancelled out. So the interesting term is this one only, right? So what we need to do in this case, third example, 5, 3, 6. So we have k equal to 3. So we can find the sum. Sum is to the power k minus 1, because we need to find the sum till k minus 1th element, right? So that is 3 minus 2. 3 minus 2 is 3 minus 1 is 2. So to the power 2, that is 4. 4 minus 1, that is 3. 3 is less than 6. Yes. That's why our answer is yes. In this case. In this case, to the power k minus 1, that is 2 minus 1. Again 2. The value we have 2, but it is not less than 1. This is not true. That's why our answer is no here. So let's see the implementation of this solution. So we need to take the input nkx, that is right. So we need to take the summation, and this is the method, like we can do the to the power k minus 1. And if this x is greater than the sum value, then our answer is yes. If it is not, then answer is no, as we have discussed, right? So this is the simple solution. Hope you understood this solution. Like this video, subscribe the channel. Thank you and keep coding.